Good evening. Welcome to our presentation about construction project management and the work plan of optimization. Our presentation consists of 5 parts: introduction, schedule, cost estimation, optimization, and observation of the work plan. Here comes the first part. Our group select the railway network command center building project in Port as our research target. The cost of the main building was about 187 million, and the actual took 380 days, including 284 working days. The work breakdown structure diagram for the main building project is shown in the figure, where the node are noted to contain the project name, project start and time, and the project time spent. In addition, this section also provides an overview of the project budget, which will be discussed in detail in a later section.
For my part is about the schedule determination, and based on my results, my team member will determine the subsequent resource allocation and cost control, schedule management, and optimization. And so in my part, I estimate the duration of each engineering unit listed in the WBS figure and sort out their sequences. Here I have listed all the bases to determine the temperatures for our project. And you can see that some are based on the CAD drawings and the given data, and some are based on the national regulations and the relevant engineering experiences from the internet, and also the calculation from the budget. And then I continue to find the information through those ways to get the sequences of each unit and arrange them, and also find the necessary pre-tasks of each unit and whether they can be done at the same time. After doing this, I input the data into the Microsoft project, the software, and to get the Gantt charts and the grid charts. And I also analyze the risk of the delay according to the condition of applying the project extensions. And there are overall 6 reasons that may cause the delays. However, 5 of them are hard to be qualified and calculated because they are all about human reasons like the policy. So here I only estimate the delay due to the extreme weather conditions, and the calculation results is shown below.
For my part, it's about the cost imitations. Unit project cost table is a detailed list of unit project costs of each part of the table. The total cost table is divided into 6 parts: earthwork, primary pipes, support system, water stops, foundation pipes, and the main structure engineering. Each part can be basically divided into measured project costs, which includes set constructions cost for the overall measures of the unit volume of work multiplied by the rate. The direct cost, which contain the transportation materials, machinery for the required volume of work multiplied by the basic price, and the labor cost for the number of the man days times the number of works multiplied by the market price. The most important parts is the main structure engineering, divided into the 3 parts, which contains the measuring works, steel works, and the main structure works. Of the total cost is about 4/5 of the total amount of the whole project.
Next part is project control. We divide it as pre-construction and during construction. The first step of pre-construction project control is aligning project with portfolio goals and objectives. As the whole railway network command center main building, completing the project on time is the most important thing. Next, develop project control plans, which consist of quality control, risk control, schedule control, cost control, communication and coordination, and change control according to objectives. The above plans are described in detail in the report. Last but not least, we set up some schedules to monitor project costs and duration during the construction, which can easily find that whether there are cost overruns and schedule delays. As for the project control during construction, the main situation is first, the Spring Festival vacation. There were significant delays in the work schedule due to the release of many workers on holidays. At the same time, there were cost overruns due to the suspension of the use of raw materials, space, equipment, and other facilities. Meanwhile, by the end of September 2018, cost and schedule monitoring revealed that the project was overspending against budget, using funds inefficiently. The cost variance were calculated as approximately minus 151,000 and lagging behind schedule. So the adjustment to project control that could be taken. First, improve efficiency and use construction personnel with better management skills and higher efficiency. Second, work overtime, catch up on work, or work in patrol while guarding against risk.
Okay, let's go to the part of optimization. Our team has made an optimization attempt on multiple construction sections considering the limited time for the presentation. Adjustment to the personnel allocation in pile foundation construction will be present in this section. We can see from the graph that the configuration of the total number of personnel is fixed, and the labor force is limited, which means that during the construction of the project, the number of people can only be kept at 12. At the same time, due to difference in construction environment and treatment conditions of workers, there may be difference in various specific construction aspects, which will result in various constraints. For example, the number of participants in the foundation pit drainage cannot be too few, and the worker involved in structural engineering cannot be allocated too much. Therefore, the allocation space is left for us limit, as shown in the Excel chart. This second page lists our optimization goal, which is to minimize the number of the construction days. At the same time, in order to ensure that the number of construction personnel is reasonable, we must define integrals. By assigning other constraint conditions to plain solution, a system optimization process is complete. In the result area, the green area represents the number of days after our optimization, while the red area represents the original total construction days. By observing the chart, it can be seen that we have increased the number of personnel involved in pile, foundation, construction, and earthwork excavation work, and appropriately reduce the number of works involved in foundation and basement engineering, thereby reducing their construction time by 13 days, which means this is very effective optimization plan. Thank you. That's all. If you have any question, we're glad to hear your guidance. Thank you again.